So for this first problem, we need to go and put this into our stat list in our calculator. So after that, I found my mean and standard deviation for each class. We got class 1 with the mean of 86.79, standard deviation of 4.39. In class 2, we had a mean of 90.7 and a standard deviation of 6.02, so a lot higher in class 1. So the average is higher there and the standard deviation is higher, meaning there's more variability. So we want to know if a student in class 1 with a 92 did better than a student in class 2 with a 92. So we're going to use z-scores. Here's our formula, z equals x minus mu over standard deviation. So I have the x for each of these, it's 92, so I'm doing class 1 right now. And we get a z-score of 1.19, which means it's above 1 standard deviation up. For class 2, we get a z-score of 0.22. So class 1 did better, in quotes, because it's a higher z-score. This next problem about kangaroo heights sort of tells me that I need to make my curve, my normal curve, so I'm going to take a sec to do that. So I've built my normal curve. Now I want to find where approximately 47.5% of kangaroos exist. So if I know my values inside of my empirical curve, I know that 34 plus 13.5 is going to be 47.5. So either I could say all the kangaroos are here, or I could say all the kangaroos are here. So we have two answers here. The kangaroos can be between 1.2 to 1.5, or they could be between 1.5 to 1.8. So there's two correct answers here. You wouldn't have to give both. You could just say this one or this one. Our next one on this page is about the PSAT. So it says it follows a bell distribution. So we might need to draw that bell-shaped distribution. But then I see the word z-score, and I'm thinking I just need to talk about z-scores. So if Wayne's z-score was a 3, and he scored a 1520, we can use our z-score formula here. So what I'm going to do is I'm going to plug Wayne's z-score of 3 in for z. X is 1520 because they told us that's his score. The mean is 920, and we don't know the standard deviation. So that's our only variable right now, so we want to solve for that. So what I can do is multiply both sides by the standard deviation, and we'll get 3 sigma equals 1520 minus 920, which is 600. And then we'll divide by that 3 and get the standard deviation equals 200. So right now we haven't actually answered the question, we've just found some missing piece. What we actually want to figure out is what was Sadie's score if we know her z-score. So now we can go back to our z-score formula, say that her z-score was 1.5, the mean was still 920, but we don't know what x is. So I have x minus 920 over the standard deviation that we just found. Now I'm going to solve for x. So we multiply by 200. We'll get 300 equals x minus 920. Add that 920 to both sides. And we get 1220 was Sadie's SAT score, PSAT score. Alright, we got a swim team with the 4x100 relay time. We do not care about these numbers, it's extra. It's normally distributed. We have our mean, our standard deviation. We want to find a proportion here. So we could start by drawing our curve, but this might or might not be super helpful. So we want to find the proportion that's faster than 2 minutes. So if we want to figure out how many are faster than 2 minutes, we need to find 2 minutes on our curve, which we actually can't. So we need to use our calculator for this. Now the trick is if we want faster, we want everybody below 2 minutes time. So over on this side here. So that means in our calculator, we're going to go to our normal CDF, and our lower value is going to be negative 999, because if we could, we'd put infinity. And our upper value is going to be 2 minutes. The mean was given to us, and the standard deviation was given to us. So we're going to go put this in our calculator. And we end up with 0.6% because it was 0.006. We round to 2 places, so 0.62 maybe. That's it. Number 5, the NRDC found the weights of 10,000 sea bass, normally distributed. We want to draw and label a normal curve, so let's start immediately with that. The mean goes in the middle, and then we add and subtract the standard deviation. Now our goal is to shade the region under the curve where the data for 1,600 below average fish are located. So we really need to find the proportion here of the 1,600 fish out of the total 10,000, and that'll give us the percent we're really looking for. So when we divide these, we get 16%. And if we remember our empirical rule, our percentages, I'm putting them on right now, we want to find where 16% of below average fish. So average is 1.5, 16% would be the combination of 0.15 plus 2.35 plus 13.5. So this whole section below that 1.42 is where 16% of our fish are located. And that's it. So we'd shade that. Number 6, your mom is creating a new license plate. That's the opposite of Virginia. She needs first 3 characters to be a number, last 4 to be a letter. So we've got 7 total blanks. The first 3 are numbers. There are 10 digits, 0 through 9. And then the last 4 are letters. It doesn't say anything about repeating or not repeating. So we're just going to multiply these guys together. And we end up with 456,976,000 possible passwords. So that's that fundamental counting principle. Number 7, your sister's setting up for game night. She's arranging a table. She's got 8 friends. Only 6 are playing. How can she select this? So if we're arranging a table, that means the order matters. Where people are sitting literally matters. She's got a table and she's trying to figure out where everybody's sitting around this table. So we want 8 to start, permutation, 6 people. We can throw this right into our calculator. And we'll get 20160. Lastly, the Senate is throwing out the Constitution. They have 100 people in the Senate, 5-member committee. It doesn't say anything about the order of the committee, like there's a leader and a vice president or whatever. It's just choosing a committee. So we have 100 people, combination, 5. So it's a combination because it's just a random committee with no leadership, no ranking, no titles. And when we multiply this stuff out, we type this in our calculator, we get this many total options. And that's it.